The specific heat capacities and specific latent heat. If the question is related to the thermal capacity or heat capacity, we'll skip as it's not part of the syllabus anymore. So mainly we'll solve the question from specific heat capacity and the thermal capacities and specific latent heat. First 4 questions I already solved, so I'll share that recorded session. We'll start from 5 onward. So in this question, compare the arrangement and the motion of the molecule in ice and in liquid water. So how the particles are arranged in ice and how the particles are arranged in a liquid water, we have to compare them. So what we can say about the ice, we can say the particles have a regular or orderly arrangement, where in water there's no regular arrangement. And in ice, the particles can, the motion of the particle, they can vibrate about the fixed position, where in case of the water, the particles can slide or slip pass over each other. So for ice, first the arrangement of the particle, they have a regular arrangement, you can say. And the motion of the particle, they can vibrate about the fixed position. Where in case of water, there is no regular arrangement. And the particles can slide or slip pass over each other. Then when we compare then the next question is the ice hockey rink has an area of 1,800 meters square. Like the total area of, like this is a ice hockey rink, means the they're playing ice hockey on this, so that area is about 1,800 meters square. The ice has a thickness of 0.025. So the thickness of the ice, so when we look from the sideways, the thickness is given 0.025. The density is 920. We have to calculate the mass. So how to work out the mass? Density is mass over volume. So mass is density times volume. The density is 920 times. How to find the volume? Because we have the area, which is 1,800 meters square, and we have the side, one of the side is like the thickness is 0.025. So we multiply area with the height, so 1,800 times 0.025. What's the answer when we multiply all of them?
45.
The mass, the total mass of this equals to 45.
No, Mr. The volume is 45.
No, I'm talking about the total mass. 920 times
Yeah.
the total.
41,400.
41,400. So 41,400 kilogram is there. That is a total mass of 41,400 kg. Then next is, in this question, the ice is at 0. To form an ice from a water, to form an ice, water at 0 was poured into the floor of a rink and then frozen. The specific latent heat is 3.3 into 10⁵ joule per kilogram. Calculate the energy removed. So first thing, you have to identify whether there is a change in state or there is a change in temperature. So when you check the question, what happened here? Is there a change in state or a change in temperature?
Change in state.
Change in state. So whenever we have a change in state, so which formula is valid here? That E is equals to M into L. So energy is equals to mass into latent heat. So these questions, the thermal physics questions, are straightforward question. Like The only thing you have to identify whether it's a change in state or change in temperature. So E is equals to mass into latent heat. The mass, because how much was formed, so 41,400 kilogram, and the latent heat is 3.3 into 10 to the power 5. So when you multiply both of them, you will get the total energy. How much is the total energy? It should be
1.3 multiplied 10 power 10.
So 1.3 into 10 to the power 10. So, and obviously it should be a large number as we are multiplying. So 1.3 into 10 to the power 10, and unit of energy is joules. So why we use this formula? Because in the question there is a change in state. If there is a change in state, we use this formula. If there was a change in temperature, E is equals to Cm delta T. In question 6, state a comparison of the arrangement of a molecule in ice and in liquid water. We just did that arrangement, like ice is a regular arrangement, liquid water, no regular arrangement. Ice, the movement, the particles will vibrate about the fixed position, and a liquid, they can slip pass over each other. A similar question is there. The mass of a ice on ice a hockey rink is 51,500 kilogram. The density is 920. Calculate the volume. This time we have to calculate the volume. So how to work out the volume? We have density is mass over volume. So volume is mass divided by density. The mass is 51,000 and the volume is density is 920. What is the volume here when you divide?
55.4.
So 55.4, and the unit should be meter cube because the unit of density is kilogram per meter. If it was in centimeter cube, like gram per centimeter cube, then our answer will be centimeter cube. And this is the same question, but we'll get a different answer as the mass is different. To form ice, the water is poured onto a floor of a ring. The specific latent heat of fusion is given. So again, we use the same formula that energy supplied is equals to mass into latent heat. But in this part, in this question, the mass is not, the previous question, the mass was 41,400. But this time the mass is 51,000. So 51,000 times the latent heat, 3.3 into 10 to the power 5. What's the answer? How much energy is there? How much energy is supplied? Again, it will be in the same order, like 10 power.
1.6 multiply 10 power 10.
Yeah, 1.6 into 10 to the power 10. When a solid is, like in this case, a liquid turned into a solid, so the forces become stronger. Yeah, the plasma, because it's a particle at very high energy, so we don't say that they have a van der Waals force or intermolecular forces. The temperature of the ice is monitored with a thermometer made from a wire of two different metals, which are connected to remote voltmeter. The junction of a wire is embedded in the ice state. This part, because the thermometer is also removed from the syllabus, the answer for this one is thermocouple. But this part is removed. Like you will not learn anything about the thermocouple, the thermometers, how it works, as it is removed from the syllabus. I will share the content which is removed from the syllabus and which one is added. So thermometer is removed from the syllabus, so we will not discuss about thermometer. The temperature of a quantity of air, the temperature of a quantity of air is increased. Describe the effect of increasing a temperature on air molecule. So if we increase the temperature of the air molecule, what we'll observe? What will happen to the molecule?
Molecules will move faster.
Molecule will move faster. They will have more kinetic energy. They will have a greater speed, or the speed increases. It's a 1 mark. So you just describe the kinetic energy increases. And the particle will move faster. You have more collagen. Actually, the term, yeah, that's true. There will be more collagen, more frequent collagens will be there, but the mark distributed for mentioning kinetic energy and move faster, not about the collagen. It's obvious that as they're moving faster, number of the collagen will increase. The temperature of a block of aluminum is decreased. Describe the effect of this decrease in temperature on the density of aluminum. Explain your answer in terms of separation. Look, when we supply the heat energy, the substance expand. Its volume increase. So when we heat the substance, its volume increase and density is mass over volume. So if the volume increase, the density will decrease. And opposite will happen when we cool down the substance. When we cool down the substance will contract or its volume decreases. If the volume will decrease, its density will increase. So we have to explain the effect, like how it will affect. The density will increase, and what is the reason for that? The substance contract as a particle come closer to each other. So what is the effect of decreasing a temperature? The density will increase. And explanation in terms of particle, the particles come closer. As a result, when the particles will come closer, the volume decreases. So the density will increase. In the next question, a road is covered with a layer of a snow. The temperature of a snow is 0. The specific latent heat of a snow is 3.3 into 10 to the power 5. The snow forms a layer of a uniform thickness on the road. Calculate the power needed to melt 0.12 kilogram of a snow in 220 seconds. First, we have to know how much energy we have to supply or how much energy we should provide to melt this. So here, what is happening? Is there a change in state or change in temperature? What happened in this question? The change in state will happen or the change in temperature? Yeah, that's right, Ahmed. There will be a change in state. So whenever there's a change in state, so you get the energy by mass into latent heat. The mass is equals to 0.12 and the latent heat is 3.3 into 10 to the power 5. When you multiply how much energy you have to supply, first you know how much energy you have to supply. What is the energy supplied here?
396,000. No, sorry, 39,600.
39,600 joules of energy you have to supply. But the question is calculate the power. And how we can calculate the power? Energy is power multiplied by time. So power is energy divided by time. How change in state? You can see the road is covered with a layer of a snow. So like example, this is a track or a road. And there is a layer of a snow. So there's a snow on this track or a road. The snow forms a layer of a uniform thickness on the road. Calculate the power needed to melt. How much energy we need to melt this snow, like turn from solid into liquid. That's why we use energy's mass into latent heat. So 39,600 joules of energy is needed to melt this 0.12 kilogram, and then we need the power. So this is 39,600, power we don't know, and time is 220. 220 is multiplied, other side it will be divided. So 39,600 divided by 220. What's the answer? How much power or how much joules every second we need to melt this
180.
ice? 180, and the unit of the power, you can say joules per second, or you can also say watt. Is it clear, this one?
Yes, sir, clear.
The next part, the snow is melted by the solar radiation in 220 seconds, exactly 0.12 kilogram of a snow melt to produce a water. The power of a solar radiation which incident is much greater than what power we calculated. Like we have to supply 180 watts to melt this 0.12 kilogram of ice. But they're saying when the solar radiations are melting the ice, the same amount of the ice is taking the same time as what we are taking. Even though the solar radiations have more intensity, like more radiations are there as compared to what power we supply. But what is the reason why, even though with a very high radiation influx or input, why it is taking the same time? Why not it's melting in a short time? What is the reason for that? Or what might be a reason, possible reason for that? So what happened? Because the radiation from the sun, most of it is reflecting from the surface. The correct answer is actually not like it's the more radiation enter the earth atmosphere, but still it's taking the same time to melt the ice. What is the reason for that? Because some of the radiations are absorbed by the surrounding, like there is like air particles as well. There are air particles in the atmosphere. They are also absorbing the energy. So it might not receive the same amount of energy. And some of the energy might be reflected from the, and most of the energy is reflected from the snow as it is a shiny and smooth surface. Like smooth surfaces have a greater reflection. So what happened? The greater amount of radiation reflected from the snow. So it does not absorb too much energy. That's why for the very like greater amount of the energy it's supplied, but even a same quantity is melted in the same time. Like we are supplying 180 watt, maybe sun is providing like 3000 watts, 3000 joules every second, but still it's taking the same 220 seconds as we were taking. So what might be a reason for that? The reason is the like most of the energy from the sun is reflected by the snow. That's why it absorbs a small proportion of it. So it's taking approximately same time. Is it clear discussion?
Yes, sir, clear.
Then in question 8, after a few minutes, the water reaches the boiling point. The water continues to gain energy from the Bunsen burner. State what happened to temperature of a water in a beaker. Water is like, what happened? It reaches a boiling point. When it reaches a boiling point, yeah, that's a good answer, as there's a no change, there's a change state. So temperature does not change. Temperature will remain constant because the state is changing as the water is boiling. It reaches a boiling point. Then specific latent heat of vaporization is 2.3 exponent 6 joule per kilogram. It takes 12 minutes for 0.095 kilogram to water boil off. Calculate the average rate. Rate of energy supplied means power. This is also a term, a common term for the power. Power means rate of energy supplied. It's a similar question, similar way we'll solve. As there is a change in state, so we'll use E is equals to M into L, where M is a mass, which is 0.095 times the latent heat, which is 2.3 into 10 to the power 6. What's the answer for this energy supplied? 0.095 times 2.3 exponent 6. How much energy supplied?
218,500.
So 280.
Yes,
This
sir.
one. So this much energy is supplied. And then we need the power. How to work out the power? As we know, power is energy is power multiplied by time. So if we need the power, it is energy divided by time. Energy is this one. And what about the time? They mentioned 12 minutes, but time should be in seconds. So we have to convert 12 multiplied by 60, it will be in seconds. So when we divide, we'll work out how much energy is, how much power is there. What's the answer for this? In watts? Because time should always be in seconds.
Equals 303.47.
303.47, so we can say 303.5 watts. So this much is the power supplied by the heater like in this case it's from a burner, like 303 joules every second.